The great Canadian scholar of innovation, Thomas Homer Dixon, has argued that social ingenuity is the key to technical ingenuity. His definition of ingenuity encompasses not only technological innovation, which is the act of creating new and useful technologies. He includes innovation that creates better institutions and social arrangements. Homer Dixon explained this relationship in his book, The Ingenuity Gap, in the following way. We need social ingenuity to set up and maintain public and semi-public goods such as markets, funding agencies, educational institutions, organizations, and effective government. If this system of institutions operates well, it provides psychological and financial incentives to technological entrepreneurs and innovators, and it aids regular contact and communication among experts, and it channels money to those technological projects with the greatest prospects of success. Society therefore needs ingenuity in order to get ingenuity, which means that it is both an input and an output of the economic system. It is this relationship between the social and the technical in innovation that often confuses people. And so I'd like to tell a story about how we were able to link the two at the National Research Council and develop some neat technology. This is David Lepofsky. He was born blind in one eye, and by the time he reached graduate school, he was completely blind. He had lost sight in the other eye. He often complained that the bus operators in the Toronto Transit Commission did not consistently announce bus stops. And as Mr. Lepofsky explained, we blind people use the TTC as our car. Obviously we can't drive. Fortunately, Mr. Lepofsky's 2 graduate degrees were in law. And so he filed a complaint with the Ontario Human Rights Commission, and after a 12-year battle, he won accommodation for this issue. And this is what the ruling states in part, is that the visibly impaired or visually impaired, this is the literal quote there, I think it should be different, but the visually impaired passengers are entitled to be accommodated, and that the TTC should implement a system that allows this or implements this. I was told of this case in meeting here in Fredericton with officials in the city government. I was looking for potential research problems. I met with Maurice Gallant and Jane Blakely, who I saw here earlier this morning, Don Fitzgerald and others. I was highly sympathetic to this ruling. It fit within my personal research interests, but I knew that it would be difficult to pitch this within the NRC as a research project, because this type of problem we would consider low technological, low-hanging technological fruit. The technology necessary to do this could have been assembled in the 1950s, though it would have been much more clunky than it is now, and relatively more expensive at that time. But I also remember experiencing this type of system in other cities around the world, like in Geneva. They already had this type of system. And so I wondered then, why was this a problem for Mr. Lepofsky? Why didn't he already have accommodation? There were certainly political and economic reasons that he had to fight this battle. The technology was still expensive at the time. There are certainly labor issues, and what I learned through my research is that bus operators have a very high cognitive load already. Many of them have to drive different routes each day, and so to learn up to 100 different bus stops accurately, which is the case in Toronto, and to speak them consistently would be very difficult. So I asked myself also then, what can we do about this? Should we do something about Mr. Lepofsky's case within my personal research program? I knew that technologies of accommodation can have significant unforeseen benefits for people outside of the groups for which they're designed. And so we can all think, for example, about the utility of a technology like closed captioning for television. We have all probably experienced trying to get a critical piece of news, let's say on the weather inside of a noisy airport, and benefiting from closed captioning. And then it's also a short leap from an innovation like that to creating other useful innovations. For example, closed captioning has been found to be useful in indexing video, which makes video much easier to search than before. I also knew that given the present state of technology, that it would be easy for us to spin off additional innovations on top of the basic technology needed to perform next stop announcement. And so that the impacts of such services would go well beyond accessibility. For example, the Canadian Urban Transit Association has long recommended the creation of information technologies to enhance public transit, which is seen as a way of increasing ridership and therefore impacting sustainability within communities. So therefore, Next Stop has obvious benefits to all riders. So, for example, I'm also a fan of Star Trek, but I'm a fan of public transit, and so I try to experience different systems around the world. I often have the experience, even with a map, trying to figure out what's the next stop, or have we reached the stop that I want to go to. Or even if I can see outside, in a crowded bus, obviously it's difficult to do that. So having next stop announcement and also having a visual display helps. And so this kind of technology would help not only Mr. Lepofsky and other people with his impairments, his type of impairments, it would help everyone. I also knew that through the existence of what we see of accelerating change in technology, which is something that Mr. Kurzweil will most likely speak about later, that we could improve upon the systems that already existed. So the research that I had looked at the time showed that most of the researchers found that they could develop accurate algorithms for doing these things, like giving arrival time predictions at bus stops and things like that. But the computational expense, both the cost of the hardware and the amount of processing that was needed was prohibitive, and so that this kind of prediction had to be done offline, and then you would use stored results, static results, which could obviously not adapt to real-time conditions. And so I knew that given the continued reduction in cost of processing and increase in processing power, that we would be able to do more than had been done before. So then what then is the role of innovation in this type of problem? There has certainly been a long-standing tension between basic research and applied research. Basic research in computer science looks at trying to understand basic principles and develop theories for basic phenomena or techniques within computing. Applied research, on the other hand, is a systematic approach to developing practical applications using the knowledge that we get from basic research. It appeared to me that Canadian industry might not be able to bear the risk in addressing Lepofsky's case alone. My investigation, for example, suggested that the TTC was looking at an American vendor to address the human rights case. And so these facts also highlighted for me the tensions between innovation for societal good, that is the innovation that's not necessarily carried out in the private sector or for the private sector, and tensions between that and innovation that's directed specifically for the market. And so in Homer Dixon's definition, social innovation, governmental organizations are needed to kickstart and support innovation in new sectors of this kind, where these kinds of tensions exist. So I was motivated to continue and work on what I call the transit info project within my Intelligent City program. The objectives in the program, my research program, this is my personal, what we call foundational research within the National Research Council, attempts to find ways to enhance civic life through the use of technology, or to contribute solutions. And contribute is a key word here, in that I don't see technology as replacing necessary social elements within this. It should be compatible. So I'm particularly interested in addressing critical community issues like the one represented by Mr. Lepofsky's case. Why did I choose cities? I chose cities. I was already doing research in an area known as e-government, and that had convinced me that cities, contrary to a lot of common wisdom or beliefs held by many people, that cities can actually be a part of the solution to societal issues, global societal issues that we're dealing with, particularly environmental sustainability. The population densities of cities and their shared infrastructure result in economies of scale that can be made, that allow changes to be made at lower costs per person and in more rapid ways. And there are some very good examples all around the world. One is a city, Curitiba in Brazil, that was able to that innovated, created an innovation known as bus rapid transit, and they were able between 1974 and 2007 to go from transporting 25,000 people a day to 2.2 million people a day. And so I worked with, initially with a student from University of New Brunswick, and we created a simple prototype that allowed us to show buses in motion on a web page, and particularly trying to see how far we could get using the Fred E-Zone, the Wi-Fi network, which many of you know is not designed for mobile applications, particularly at high velocity. But nonetheless, it was a free living lab that we could use to explore this. This caught the attention of a company in Moncton called Red Ball Internet. They're a provider of mobile broadband service, at the time using a technology called iBurst, which was designed for mobility at high velocity, such as in buses. And they had already been providing a service for the Kodiak Transit service in Moncton. Some of you may have seen it. That allows people to see their buses on a website, and they also provide mobile hotspots in the buses using Wi-Fi. They were interested in the next stop issue, Mr. Lepofsky's case, but they also wanted to go beyond that and develop a more comprehensive set of systems, such as arrival time prediction at bus stops. So if any of you use transit here, you get to a stop and you wonder, has the bus already passed or not? There's a certain window of time when you get there and you're not sure. So these are the kinds of things that they wanted to implement. So we we developed a formal collaboration with them and developed an open-ended platform that addressed the issues not only of next stop announcement and display on buses, but also a comprehensive set of services for riders and for administrators, the transit administrators. And we learned through working with Red Ball in their market analysis, which showed that the services for the administrators were probably more important for convincing a city to adopt this kind of technology. And these are things like the ability to manage their fleet, to run reports on whether the drivers are accurately sticking with the schedule and so forth. So our approach was to use Red Ball's wireless broadband service, but they also, we worked together to identify some low-cost embedded computers, much more powerful than the ones that they had been using at the time. We in the National Research Council had experience in using different forms of web service technology to create what we call service-oriented architectures. These allow us to create systems that are easy to expand, easy to change, and easy to provide over IP networks. And so what this brought us was the possibility to create far more advanced services than have been made available before at a lower cost. Some of these systems have existed for quite a while, and it's only the larger cities that can afford them because they're turnkey systems. They tend to use a lot of closed technology. And so we were able to create a lower cost modular system affordable to medium and small cities. The outcome, we were able to transfer our knowledge in this area to Red Ball. They in turn exchanged their knowledge in working in transit. The economic impacts. Just this year, a company here in Fredericton, which creates transit buses, they customize transit buses, has made an agreement with Red Ball to outfit their buses with this technology. We're pursuing spin-offs with Red Ball. Recently, we've been told that there's a city that has just made the first agreement with Red Ball to install this system. This technology, again, is in line with the Canadian Urban Transit Association's recommendations. And for me, a personal win is that we were able to address Mr. Lepovsky's case. I have to say, just a personal note, in my decision to come to Fredericton, I came here from Albany, New York. I was a professor down there, was the fact that I saw Fredericton as a living lab, a potential living lab, and that we have this Freddy zone, but also the city also demonstrated a culture of innovation and openness. I've been able to go and talk to city officials. They have also a policy of open data. So the data on the locations of bus stops, for example, or the street center lines, they're all open and free, and so we were able to make use of them. So in the end, the experience has shown that these are false dichotomies, and what we actually have is that these kinds of cyclic relationships. There are other ways to represent innovation, the sigmoid curve and so on. But I like to view them as cycles. And so, for example, in the basic research, we used a lot of basic research results in this project, Great Sphere mathematics, a lot of distributed computing principles and so on, spatial database indexing. But that fed into the application of the technology in order to create this solution. And so we ended up, in targeting innovation for societal good, ended up creating something that is marketable by Red Ball Internet. It's also important, finally, to recognize that there are cross-cutting dynamics within this cycle. the dynamic of accelerating change. For example, the computer that we used in this project starting in 2009, there is a computer that will be announced this month that runs 40% faster at 1/10 of the price. And so that what that means is that we will be able to extend this technology even further at a lower cost. There's also, for us developers in the room, we recognize that technology has become democratized in that there's a lot of free and open source technology, both on the software side and the hardware side, that's available that makes it easier to get in and begin innovation. And also the development communities online. I saw a tweet up here talking about jQuery. Somebody was recommending using jQuery. Finally, the need for transdisciplinarity in work. These kinds of problems require the ability to cross different disciplinary boundaries, not just computer science, but understanding the operating environment in transit, understanding the social context. And Scott and Cosman's work also represent that. If you have any questions about this or want more details, please come and see me. Thank you.
Well done, gentlemen. We have 5 minutes for questions. Let's start with a question for you, Scott, about OmniBid. And the question is, isn't the quality of human persuasiveness a key equalizing factor in human negotiations?
That's a good question. I would argue that it is not an equalizer, but very much the opposite, I think, because some people are just so much better at it than others, right? And so obviously the people that are more persuasive or whatever other positive qualities you might have in negotiating, those will typically win, I would think. And so, which works out good for them, for the winners, but if you're talking about an overall society of people, a marketplace of people that are negotiating with each other, it won't result in a lot of necessarily fairness, and as a result, you will have much less trade because more people will win. And the more people you have winning, the more people you'll have losing as well. So, good question, though.
Okay, here's here's another question that addresses why does the NRC do these type of commercial projects? Who wants to handle that?
I can take that. Well, again, from my presentation, the NRC, under the NRC Act, really recognizes that private industry often needs help in kickstarting innovation in new areas. To develop technology in a new area costs a lot of money. Often the private sector doesn't have infrastructure to do that sort of thing. Any of you who have been to the Ottawa airport and drive out, you see the huge wind tunnel there. That's perhaps one of the biggest wins for the National Research Council in terms of helping companies like Bombardier to develop its products. And, if they had to create that type of infrastructure, they might not exist.
Another question about OmniBid. Excuse me, so Scott, this will go to you again. It's from Dr. Travis Daly. He wants to know, would they sell this technology to eBay for the right price?
Absolutely.
Let's see the price first. Okay, let me just see. We have time for probably one more question. Let me just look for one here. Again for OmniBid, so Scott, you're up again. Can you elaborate more on the technology used for these agents?
Yes, sure. There are a number of already kind of base software out there for building agent systems that you can work on. So to name a few, like the one I use is Jade, which basically you can program in the Java language very easily if you're able to know that, and you know a few of the commands and so on that are specific to Jade. You can very easily build these agents, and it comes with the platform as well. So basically, it's a pretty easy startup if you have some knowledge in Java. And there are a number of other platforms as well for different languages.
Gentlemen, great presentation, gentlemen, and Cosmin, great reaction to your using Klingon. Well done. Thank you so much for your expertise, and thank you for your time. We have gifts, and we'll be moving on to the next section of the program. Thank you very much.
Thank you.